Evening students, today we are going to learn definitions and statements in rotational motion. So here first of all we are going to study moment of inertia. Moment of inertia of a rigid body about a given axis of rotation is defined as the sum of the product of mass of each particle of the body and square of its distance from the axis of rotation. Here if you consider a rigid body consisting of n particles of masses m1, m2, m3, m4 up to mn respectively, and suppose r1, r2, r3, r4 up to rn be its distances from axis of rotation, the moment of inertia I about the given axis is given as I equal to m1 r1 square plus m2 r2 square plus and so on plus mn rn square. So we write in short, moment of inertia I is equal to summation I is equal to 1 to n mi ri square. Also we can write the moment of inertia in terms of radius of gyration, that is also equal to m into k square, where k stands for radius of gyration. Now we are going to define radius of gyration. K. The radius of gyration of a body about a given axis of rotation is defined as the distance between the axis of rotation and the point at which the whole mass of the body can be supposed to be concentrated so as to possess the same moment of inertia as that of the body above the given axis. Now we are going to study the statement of principle of perpendicular axis about the moment of inertia. The moment of inertia of a plane lamina about an axis perpendicular to its plane is equal to the sum of its moment of inertia about two mutually perpendicular axes in the plane of the lamina and intersecting at the point where the perpendicular axis cuts the lamina, and therefore Iz is equal to Ix plus Iy, where Iz is the moment of inertia about z axis, Ix is the moment of inertia about x axis, and Iy is the moment of inertia about y axis. So here this is the diagram here, that is in that Ix, Iy and Iz, these three axes are mutually perpendicular to each other. So here this one is the statement of theorem of principle of perpendicular axis. Like, share and subscribe to my YouTube channel.